Designers can no longer consider interior window systems such as blinds, shutters, shades, and drapery as purely decorative treatments. With increasing concerns about energy conservation, daylighting, and acoustic control, window systems assume an added importance in planning commercial interiors. Window coverings help control the environment. They regulate the amount of light or solar heat gain, glare, muffle noise, insulate, and provide privacy. Window treatments are vital to the energy performance of a building and comfort of its inhabitants. Window treatments must be calculated into the heating and cooling loads of a building. Factors to consider when selecting window coverings contributing to a building's efficiency include shading from solar heat gain in the summer month and insulation from building heat loss in the winter. In commercial buildings, solar radiation is the primary source of heat. When the sun hits a window, some of the heat energy is reflected and the rest is either absorbed by the glass or transmitted into the interior. Reflected solar radiation bounces off the surface and does not penetrate the glass. Absorbed solar radiation is soaked up by the glass and eventually is scattered. Transmitted heat energy penetrates the glass and heats the building's interior. On a regular 1/8 inch thick clear glass, around 6% is reflected back, 5% is absorbed, and 89% is transmitted through the glass. When surfaces inside the room absorb this, it is converted to heat. In the 1960s, the American Society of Heating, Refrigerating, and Air Conditioning Engineers established a procedure for estimating the solar heat gain of a window system. The total shading coefficient is a measure of the total amount of heat passing through the glazing compared with that through a single clear glass. The shading coefficient is derived by comparing the solar radiant heat transmission properties of any glass with a clear flow glass having a total heat transmissions of 0.87. Emissivity is the counterpart of reflectivity. If a material has a high reflectivity, then it has a low emissivity. Low emissivity or low E materials allow the visible spectrum of light through while reflecting back a large portion of the thermal radiation. Heat energy moves from a warmer to a colder substance by conduction, convection, or radiation. Conduction is the transfer of heat energy through a substance. Convection is the transfer of heat energy through air. And radiation is the transmission of energy by invisible light waves independent of a substance or air. These three factors determine a material's thermal resistance. The R value measures the insulating effect of a material, that is, the material's resistance to the flow of heat. Blinds are window coverings made of a series of evenly spaced slats that may be opened or closed by tilting mechanism. They can either be vertical or horizontal. Shades can be used alone or with curtains or draperies. Shades can either be of a roller shade or pleated shades. Shades are the most effective type of interior protection against heat gain, specifically a light-colored window with an opaque roller shade. There are no strict industry definitions differentiating draperies from curtains. Draperies refer to a line treatment with stiffened constructed heading requiring a traversing rod and carriers. Curtains are typically unlined and have a gathered or sheared heading. Curtains are often not intended to be opened. A lining is a fabric backing that can enhance the drapery quality of a fabric. It can increase the energy performance of a window system, and it protects the drapery from UV radiation. A drapery panel with one-way draw operation is one that opens entirely to one side. A two-way draw means the panels meet in the center and open to either side.